that. So it is important to understand some few concepts when it comes to interior design. All right. Finally. Wow, it's 1 o'clock. You guys have 5 more minutes. Let's go through this. That's all I have. Okay, 5 more minutes. This was the main topic that I wanted to talk about. All this additional stuff took a long time. Daylighting is what we're going to talk about, right? And unlike what we've always done when it comes to daylighting, this is a technique that's been apparently used worldwide, mostly in Europe, that we should start looking into more often. And it's called the PSALI technique, which stands for Permanent Supplementary Artificial Lighting Interiors. So what that means is it assumes that my primary source of light is daylight, to start off the bat, for 2 reasons. One, non-residential buildings mostly operate during daylight hours. So it doesn't make any sense to not rely on daylight. And then secondly, relative to the color constancy, our eye also does the light constancy. If, like we talked about, if you're in a dim lit space, after a few moments in that space, your eye adjusts to that dim lit space, and it still picks up different variations. Likewise, if it's a very bright lit space, your eye adjusts after a certain time, and that's the light constancy. And if it happens rapidly, that's what glare does. But if it happens at a slow pace, which is what natural light does, it changes the brightness of the environment at a slow pace. When that happens, then our eyes adapt to that much better, right? For those two, and there are several other reasons, but these are the important reasons why it's assumed in this technique that our primary source is daylighting to start with. And then we supplement that with artificial source when we lack daylighting source. So, good, everyone? Okay. So, this is something we do, but it's just a different spin on that, because we normally just design the artificial lights first, and then we come up with our independent of this, and then we come up with our daylighting solution. We just try to figure out how many we can offset. But this technique wants us to start off with saying, all right, I'm going to knock off a certain zone of on the perimeter first with daylight. I don't need any light in that zone at all. That's the given assumption. You may need light for night, but during the daylight hours, during a normal non-residential building occupancy, the assumption is I don't need for the first for a certain depth of the floor plate, and that's the lighting zone. So it assumes that that's what I'm going to do, and I'm going to design my fenestration based on that. Then the rest of these fixtures are called the PSLA lights, because they are all equipped with the controls, with dimming controls and other photocell controls. So let's say you have a window here, and the required illuminance on the work plane, which is typically 30 inches above the finished floor, is 50 foot candles. Then if you achieve minimum daylight conditions for some, in the morning it's overcast, so that's when you'll have the minimum daylight condition. When you don't have the overcast situation, you have a very clear sun, you may have an average daylight condition, and the maximum daylight condition is when everything is perfect. You may not have that all the time. So during the minimum daylight condition and during the average daylight condition, if you notice, at the work surface, you can design so that this zone, edge to edge, this zone will never need artificial light. And depending on how big this window is, you can keep increasing this zone. So as a design philosophy, we should establish this right off the bat, saying, all right, I'm going to the first 10 feet, I'm going to design it in such a way that I don't need any lights at all. And then the rest of them, I will change based on the amount of light that's available. So in order to do that, we first establish a lighting budget. It's called LPD, typically, lighting power density. And this is a fact, this is a number that is required for the 2030 reporting starting this year. So we haven't been usually calculating this or capturing this in our designs. We typically look at amount of energy consumed per square feet per year, the EUI, but we should start looking at capturing this. Typically, lighting codes will allow for a school 1.2 watts per square feet, but our lighting budget may say, that's all I'm allowed, 0.8 watts per square feet. Then our guys typically get that between 0.8 and 1.0. But this PSALI lighting budget, we should also establish that. We should establish something, I'm just giving an example of 0.6 watts per square feet, meaning that even though my connected watts per square feet is 0.8 watts because I have 4 lamps or 4 fixtures, my through PSLE techniques, 1/4 is gone because I'm not going to ever light that up. So then you establish a certain budget and you strive to achieve that. It's a different way of thinking about this. So right from the beginning, we start establishing lighting control zones and lighting control methods.
That's good only when you have daylight. What happens to that 25% of time? Stuff.
Well, actually,
that's what I'm saying. Most of the non-residential occupancy types that we deal with, offices and whatnot,
for those
occupancy types. But as soon as you go into residential and other types of prisons and whatnot, this may not be an effective strategy.
we can lower significantly how much lighting we do. We tend to generalize and provide the same level of foot candles in a classroom or in a library. But in fact, like a library, the amount of lighting you need in computer areas is very different than you might need in a staff area or in an area where you're having casual seating. And we need to start fine-tuning those levels because they can be brought down immensely from 50-foot candles.
It's a very good point. I can show you a library lighting plan right now that doesn't.
But that's different than this. This is saying that we need to be switching the lights all along the windows separately.
Well,
right?
Yes,
but it's
right.
It's a way of lowering our energy.
It should be controlled differently. So that's a technique that we start with right off the bat during design.
Right.
We assume, hey, we're not going to light this thing at all. So this should be wired separately.
Right.
So that changes your lighting philosophy.
But how do you teach the teachers not to turn the light on? The second they walk in, they're going to turn them all on.
Lighting controls, automatic lighting controls will solve that problem.
I don't think they're.
And the recent lighting codes don't allow users to override the lighting level. So that will be a moot point.
What do you do when you have large spaces that you're trying to keep very flexible because the school wants to be able to move things around? If you have 3 tasks in one large space, you can't really confine it to the task because in a year or 2 they might move things around and those tasks will be different.
Right. And it goes back to our earlier discussions on for a type of space, we have to establish those questions right off the bat. Do you want that flexibility?
A 2030 challenge, you've got to start bringing that stuff up. You can't just say you do anything at will.
Right.
Go ahead and turn up.
So we need to raise that question.
We encourage flex use space because space is at a premium.
Well,
And then
Even within flex use spaces, you could have zone lighting, and that's where it starts. If we assume we're going to get a lot of light in the first 10 feet or 20 feet, then we have to define the zone because you can get more. You can have multiple zones on the south side, but north side you may only have a shallow zone. On the east and west, you're going to have different depth for the zones.
if you accept the 2030 challenge, it's a different convention. You got to start thinking and selling things differently.
Okay, this is the last one. John, this is for you. Remember a couple of weeks ago you asked me 90 square feet? This is the simple rule of thumb for calculating daylighting fenestration requirement. But what I'm going to tell you is this is very, very approximate. And I don't have the time to go through all this, but maybe next week we'll talk about it. on daylighting rule of thumb